Welcome to another video from DFS on Technology. In this video, I'm going to talk about my home phone system. So let me show you my home phone. It's this. Now, for those of you who don't recognize this, it's an old thing called a landline. You might have thought they were extinct, but in the immortal words of Monty Python, they're not dead yet. Now, I don't connect my analog phone to an analog phone line from a service provider. Instead, I use voice over IP. So I connect my analog phone to a little box called an analog telephony adapter, or ATA for short, and it converts the analog signals to voice over IP digital signals. Now, any normal person would configure the ATA to connect directly to their voice over IP service provider, and that is precisely what I didn't do. Rather, I have configured my ATA to connect to a server that is running Linux and Asterisk. Asterisk being an open source PBX program. And then the Asterisk server connects to my voice over IP provider. So in this video, I'm going to take you on a tour of my Asterisk system. So along the way, we'll take pit stops at things like Dialplans, Perl even, Postgres, and all kinds of cool, weird, and wonderful open source software. So buckle up, and let's go take a look at Asterisk. Alright, hello. Here we are on my Asterisk server with a terminal open in the Asterisk configuration directory. Asterisk has many configuration files. I'm not going to go into all of them because this isn't a tutorial. I'm not going to teach you how to install Asterisk. I'm just going to show you an already installed Asterisk system and some of the cool stuff you can do. So the most important configuration file is the Dialplan, which you might expect would be called something like dialplan.conf, but it isn't. It's called extensions.ael, where AEL stands for the Asterisk extension language. So let's take a look. It's just a plain text file. Up top, we have a section called globals, which defines, in my case, two global variables. One is called ext, and this is short for the external extension. The external extension uses a protocol called SIP, which is a voice over IP protocol. I think it stands for Session Initiation Protocol. And the name of the external peer, because SIP has a concept of peers, is TechSavvy. That is my voice over IP provider. It's an ISP here in Canada. The second variable, int, is a list of my internal extensions. They all use SIP. Guess they're thirsty. And they're called 1, 2, and 3. Now, 1 is the little ATA box that I showed you earlier in the video. 2 is my cell phone, because I sometimes use voice over IP on my cell phone. 3, I have no idea what it is. I think I used to have another extension, but I no longer do, but it doesn't hurt to leave it in. So those are the two global variables. Then within an Asterisk Dialplan, there are two really important concepts to understand. The first is the concept of a context. A context is sort of the starting point for call processing, and different calls can start in different places. In my case, if I dial out, so if I pick up my phone and dial out, I start from a context called internal, and I have access to a bunch of other contexts. That's what all of these are. I just split them out for ease of management. On the other hand, if somebody calls my house, so it comes in from the outside world, then they start from another context, which is called external, right here. So all incoming calls begin life here. The second important concept is an extension. An extension might be a number, like if you call an office and somebody has an extension like 231 or whatever, that's an extension. But there can be special extensions, and one special extension in Asterisk is the S extension right here, which is the default starting point for a call. So here, when somebody calls me from the outside world, the call starts off in the external context, and more specifically in the S extension. So here we go. Let's see what happens to a call that comes in. So we start here on this line. The first line, begin, is just a label. It ends in a colon. It doesn't mean anything. This line sets the volume a bit louder than it normally would be because I find my phone is a bit soft. This line answers the call. So at this point, whoever's calling me has been hearing ringtones. At this point, they hear a click and the ringtone stops. It's as if somebody picked up the phone. No op does nothing except print a little message to the Asterisk console. These three lines, starting here with the if, let's move the cursor down there. Take a look at the caller ID number, and if the caller ID number happens to be anonymous, we just set all of the caller ID to blank because that's a garbage caller ID. Then this line here calls a built-in asterisk function called Privacy Manager. And what that does is if there's no caller ID, it prompts the caller to enter their phone number. And it has to be between 3 and 10 digits. I believe that's what those numbers mean. Yep. If they don't enter a caller ID, in other words, if the Privacy Manager status is failed, we go to a label called Privacy Bad. So let's zap on down to Privacy Bad. Which if I could type, I would be able to find. Privacy Bad. And all that Privacy Bad does is hang up. So if you don't give me your caller ID, you don't get to speak to me. The next couple of if statements, so this one and this one, look for two known telemarketer numbers, and if the caller is from one of those numbers, they go to a context called Lenny, and we will meet Lenny later on in this video. If the caller ID number is 10 zeros, which is a garbage caller ID, we just hang up, go to Privacy Bad. So that makes sure that I have some sort of sensible caller ID at this point. Next, these two if statements check if the caller ID is from my local calling area. Where I live, there are essentially two, what I would consider local area codes, 613 and 819. So if the caller ID number starts with 613 or 1613, or it starts with 819 or 1819 and has 7 more digits, that's what this pattern match means, we go to a label called isLocal, which we'll meet later on in our journey. Next, if it's not a local number and the name, the caller ID name is a number, this is a regular expression match, this matches a bunch of digits, we say, okay, that's likely a telemarketer. So we go to telemarketer, which we will meet later on in our journey. Over here, we print to the Asterisk console, hey, we've got a non-local number. Then we look in our database. This is what this does. It looks in a database. And it says, do we know this number? Because I do have some long-distance numbers that I receive calls from on a regular basis. If we find it, we say, well, it's as good as a local number, so we go to isLocal. Down here, it is not a local number. It is not a known good long-distance number. The caller ID name might have been a number. So we log to the system log, hey, I got a non-local call. And then we play a sound called not a telemarketer. And I will play that sound for you right now. Let's go. Here we are where the sound lives, and let's play it. You have called from outside the local calling area. If you are not a telemarketer, please press 1 now. That's because a lot of telemarketers use dialing machines that don't actually connect you to the telemarketer until you answer. This way, and the dialing machine is not going to be able to press 1. It's not going to know to do that. This way, you're pretty much assured you're speaking to a human. So we give them 2 chances. We say, press 1, and then we wait for 8 seconds. Then we say, come on, press 1, and we wait for 5 more seconds. If they don't press 1, they get to speak to Lenny, who we will meet later in the video. If they do press 1, what ends up happening is waits for them to type an extension, and they end up in an extension called 1 down here, which just goes to is local, which is right here. So basically, if they press 1, they end up here. If they don't press 1, they get to speak to Lenny. Next up, we take a look at the caller ID number. This line checks if it's from Rebecca, and if so, it sets the caller ID name. And this one checks if it's from Bill, and if so, it sets the caller ID name. Because these people's cell phones only set the caller ID number, but I know who they are, so I want my phone to display their names, so Asterisk fixes things up. This is a little do not disturb feature, which I'm not going to describe. I will describe it later on in the video. We're almost at the point where it's going to make my phone ring. Only a couple more lines to go. System executes a Unix command, a Linux command. And the command that it executes is this. It basically announces that there's an incoming call starting and who it's from. And I will show you later on in the video where these announcements go. I set a variable called left voicemail or left VM to false. And I dial the 3 internal extensions. Now, at this point, if I answer the phone, Asterisk sits in this line for the duration of the call. So if I'm on the phone for 25 minutes, we sit here for 25 minutes. But whatever happens when we're done with the call, or if I don't answer it, or if I'm busy, we go to an extension called S- and then the dial status. And there are a bunch of different dial statuses. So one dial status is busy. So if I'm on the phone, we go here. It sets left voicemail to true, which means we're going to give him a chance to leave a voicemail. We count how many voicemails we have so far in the mailbox. And then this lets them leave a voicemail. It prompts them to leave a voicemail. And the B means give them the busy message. So they'll get a message saying, I can't answer the phone because I'm already on it. Please leave a voicemail. We wait a second and then hang up. Any other dial status is very similar. We set the left VM flag, we count the number of voicemails. The only difference is they get the unavailable message. So rather than I'm busy, please leave a message, they get a message that says I'm unavailable, please leave a message. When all the dust settles, whenever I hang up or when the caller hangs up, Asterisk always jumps to this special H extension. And this is basically the cleanup when the call is done. So let's see what happens here. If they were given a chance to leave a voice message, in other words, if this left VM is true, and if they actually did leave a voice message, in other words, if the number of voice messages we have now is greater than the number we had just a minute ago, then if it's between 8 a.m. and 10 p.m. on any day of the week, run this command. And this little command sends a text message to my cell phone saying, hey, home voicemail from blah, 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 blah. Isn't that cool? We also announce, we've seen this announce call command earlier, that they left voicemail. And then we announce the call's over, goodbye, and that's it. The call's done. So that's how incoming calls work. Here we are in my living room, and I'm going to call my home phone from my cell phone. But I don't want you to watch me while I do that. I want you to watch my gadget. Now let me take the camera and point it at my gadget. Okay, there we go. I hope you can see that clearly. That is a tiny little Raspberry Pi 3 mounted under my television, and it has a little 3.5-inch, I think, HDMI display. And that display shows a bunch of things. It's got a weather ticker, that's the top line. It's got a news ticker, which is the next line. And at the bottom, it prints pithy sayings from Linux. Now let's see what happens when I call my home phone number. So I'm grabbing my cell phone, opening up the phone application and calling my house.
Incoming call from Diane Cell 613-555-0098.
What? How did that happen? How on earth? And it announced the caller, like visually and by voice. We're gonna have to go back upstairs, back in front of Asterisk, and look at what the heck is going on. Okay, so down in my living room, we saw that the phone number was announced both visually and audibly. So how did that work? Well, I'm going to open up a program that's called an IRC client. For those of you who are not familiar with IRC, it stands for Internet Relay Chat, and it's a multi-user chat room program that's been around for many years, since probably the 1980s. It's essentially Slack or any of these chat programs except ancient, and free and open source, and a much simpler protocol than Slack or any of those competitors. Anyway, I run an IRC server in my house that's only accessible from in my house. It's called Ollie, and I have a channel called Ollie. So let's see what happens when I call my home. I'm going to pick up my cell phone and dial my house right now. So let's go. As you can see, a notification went out on the IRC channel. I'm going to hang up now, and there we go. Another notification went out on the IRC channel. Who's doing this? How is this happening? Let's take a look. I'm just going to close the IRC client, go back into our Dialplan, and go to the magic that's making those messages go out over IRC. So here we go. Now, I don't know if you remember when I was going through the Dialplan, one of the things that happened just before my phone rang, my phone rings here in Dial. So just before that, we run this thing called announce call. So let's take a look at what announce call looks like. It's a one-line shell script that calls another script called IRC notify with a nickname of phone. If we open up the IRC window, you'll see that the chat message appeared to come from somebody called phone. And the type equals call, that's this. Event equals the first parameter, so incoming start. The num is this, and the name is Diane Cell. So that gets splat out onto the IRC channel. I'm not going to show you IRC notify because it's pretty boring. But what I am going to show you is the software that lives on the Raspberry Pi and announces the call audibly. So let's switch directories. I have an IRC bot, which is nothing more than a program that sits listening on an IRC channel. And again, if we open up the IRC client, you can see that not only am I in the channel, but there's a couple of bots, actually 3 bots. I'm not going to talk about all of them, but the interesting one that I'm going to discuss is called Pi3 bot. This is a bot that lives on my Raspberry Pi 3. It's written in Perl. Now, I know what you're thinking. She has a landline. Of course she'd program in Perl, because that's what dinosaurs do. But no, Perl is still a very live, useful language. I'm not going to go into the simple bot in huge detail because it's a little bit complicated, but I will go into the plugin that announces phone numbers so we can see how that happens. Now, the way that this works, and I don't expect you to understand Perl. You don't have to understand Perl. I'm going to explain. Basically, every message that gets splat onto the IRC channel eventually gets passed into a method, a subroutine called handle. And it gets passed a whole whack of parameters, most of which we don't really care about. But the message parameter is the actual message that gets put out onto the line. So if we open our IRC client, the message is all of this stuff, starting from type equals call, blah, blah, blah. So how does this work? Well, if it doesn't match type equals call, we just ignore it. That's what this line does. Do nothing unless it matches type equal call, because I have other things that spit other messages onto the IRC channel that should be reacted to by other bots. This just converts the line into what's called a hash, which is like a dictionary. So if we look at the line, you'll notice that it's formatted very specially. So this line to hash converts this string into a dictionary where the entry type has the value call, the entry event has incoming start, the entry num is that, and the entry name is Diane Cell. This lets us look at the various pieces more easily. So here we go. If it's not incoming start, we ignore it. So in other words, we ignore this one. We don't do anything with incoming end. We only care about incoming start. If we're in do not disturb mode, which I'm not going to explain at all, don't do anything. But basically this lets me shut the thing off at night so it doesn't announce callers. Okie doke. Moving along. We get the number. That's the num part. If we look here, you can see this 3-letter thing, num is num, and the name is the name. So we get those. If the name and the number are the same, we just set the name to nothing, because there's no point in announcing the same thing twice. This little chunk here, basically, if the name matches a bunch of digits, we add spaces, or commas rather, in between groups of 3 and 4 digits. That's to make the text-to-speech part that we're going to get to later on read it more naturally. Otherwise, it just reads it as a giant 10-digit number, and it's impossible to understand. So this adds pauses in the right place in the name. This does exactly the same thing, but for the number. And then we call this thing called Pico to wave handle, which is right here, which ends up calling speak. And it says incoming call from name dash number. So let's take a look at speak, which is not defined in here, but it's defined in here. Here we go. This is speak. So basically, we're given a bunch of text that we're supposed to speak. We create a new directory, just a temporary directory. Now this is magical because when this subroutine exits, that directory will be deleted. That's just a nice little Perl module. If for whatever reason we couldn't create the directory, well, there's not much we can do, so we just exit. Then we run a program called Pico to Wave, which is a free text-to-speech program that is available on Linux. And we write our speech out to this file, out.wave. So it converts the text into a wave file. And then we play the wave file. Right here, we play it. And then we return 1 saying, yep, it worked. And that's how the number gets spoken. And I can give you a little demo of Pico to Wave. So if I go, I hope I have it installed on this computer. If I go Pico to Wave minus w temp foo.wave. Hello world, how are you today? It does something. It created a wave file, so let's play it.
Hello, world. How are you today?
Not the most fluent or easy to understand, but certainly you can discern what she's saying. So that is how the number gets announced audibly. Now, how about the little visual flashing? Well, the visual thing, I wrote in a different language called Tickle, or TCL, which originally stood for Tool Command Language, but now it just stands for Tickle. And I'm not going to show you the code for that because it's way more complex, but the basic idea is the same. It sits in an infinite loop. That one's called T830, that's the name of the Tickle bot. And it reads messages, and when it sees an incoming start, it flashes the caller ID number. So that's how my little Raspberry Pi call announcer works. Isn't it cool? Okay, so now we've seen how incoming calls work. How about outgoing calls? Now, you may remember, you probably don't, but you may remember that incoming calls start in this context, the internal context, which basically just includes a bunch of other contexts. And what this does is it takes all of the extensions in all of those contexts and essentially makes them part of internal. So let's skip specials for now. Let's look at local 10. So context local 10. Let's put that guy at the top of the screen. This is for local numbers dialed with 10-digit dialing, and they all pretty much match the same thing. So this extension, it starts with an underscore, so it's a pattern match. It matches anything that starts with 613. N matches 2 to 9, and X matches any digits. So it's 613, 2 to 9, followed by 6 more digits. In other words, a 10-digit local number. We basically dial the extension on the external SIP peer. So this goes out via TechSavvy. We dial it. I set a maximum call time of 10,800 seconds, which, come on, it's 4 hours, I think. Am I right? Am I right? Am I right? No! Math fail. 3 hours. I set a maximum call length of 3 hours, which shouldn't be necessary, but just in case Asterisk goes nuts and never hangs up, at least it'll eventually hang up. And the basic scheme is we announce an outgoing call, we dial the call, and as long as I'm on the call, Asterisk will sit on this line, and then it announces we're done, and it plays congestion, which is a fast busy signal, which is a signal to me to hang the phone up because the call's over. 819 is another local area code, and the two variants here with the *67, that's *67 is a feature code for suppressing caller ID. So if I dial *67 on my end, I want to pass that along to TechSavvy. So basically this dial *67 613 and then the rest of the extension. And I believe I have a bug in there. I think that should probably be more than 3, but don't worry about it, smoke and mirrors. Because I don't use 10-digit local dialing anyway. I'm lazy. I use 7-digit local dialing. So let's see what that looks like. Here we go. Local 7. That just matches 2 to 9 followed by 6 other digits. And it automatically puts 613 in front of it for me because that is the local area code most of the time. And why should I dial 613 when 99% of the time I don't have to? I'll get Asterisk to do it for me because I'm lazy, and laziness is a virtue when it comes to computers. Okay, so that's local 10 and local 7. Let's take a look at long distance. Here's long distance. Oh, something interesting going on here. This matches a 1900 number. Now these 1900 numbers you have to pay for. So I don't want people to be able to dial that from my house. So let me actually do that. I'll pick up my landline and I will dial a 1900 number.
I'm sorry, I can't let you do that.
There we go. It waited for a second, it played, I'm sorry, I can't let you do that, and then it gave me a fast busy. Same thing if I try to suppress the caller ID before dialing a 1900 number. Okay, so those are the ones we don't want to dial. The ones we do want to dial work pretty much the same way as the local 10 extension. We just dial them. No problem. Alrighty, so that's the long distance calls. Now long distance here means within North America. If we look at international, basically that's anything in Canada. To make an international call, you start with 011 and then whatever. So basically if it sees 011, it dials it. So now the reason I've separated these out into separate contexts is, for example, I could give somebody a different local extension in their room if they're staying with me, and I could forbid them from dialing international calls by having them start in a context that doesn't include international. All right, that's international. Oh, 911. So 911 is, if you dial 911, we dial 911. So I had to put that separately because the other extensions only match 10-digit numbers or 7-digit or international. So 911 is in its own little context. Parked calls. That doesn't exist. That's a bug. So we won't look at that. And finally, my favorite part of the Dialplan, specials. So here we go. If I dial 2 asterisks, which I don't think work because my ATA intercepts that, I get my voicemail. If I dial 911, I can leave myself a voicemail. So let's do that. I'll dial 999.
Hi there. Someone's on the phone right now, so please leave a message.
Please leave your message after the tone. When done, hang up or press the pound key.
Hey, I'm leaving a message. Bye.
Thank you.
Right, so that left myself a message. Now, actually, if we were to look at the Raspberry Pi down in the living room, which I'll do, you'll see that it indicates I have a voicemail waiting because it monitors that. So let's listen to the voicemail. 111, extension 111, takes me to voicemail main. Voicemail is for leaving voicemail. Voicemail main is for listening to voicemail. So let's listen to the voicemail. Here goes.
You have one new message. Press 1 for new messages. First message received at 7:32 p.m.
Hey, I'm leaving a message. Bye.
Press 3 for advanced message deleted. Goodbye.
And there we go. That was the voicemail that I just left a moment ago. 113 goes to a context called monkeys. What? Let's take a look at monkeys. It doesn't do very much, but it's kind of fun. Let's dial 113.
They have been carried away by monkeys. The monkeys. The monkeys.
I used to send telemarketers to the monkeys, but now I reserve a much crueler fate for them. Now, telemarketers go to Lenny. I promised I'd show you Lenny, and here we go. Here's Lenny. Lenny. Let's get Lenny at the top. Okay. So there's some stuff that just sets some volumes. And then we wait for silence. So what usually happens is somebody will call and we wait for silence. We then start recording. And then we play a sound called Lenny. Hello, 01, pause. So let's actually listen to that sound if I can find it. If we listen to that sound, we get
Hello.
just hello. Now, some telemarketers are smart. They start out with a recorded message, and you have to press 1 to get connected to their agent. That's how they can detect that they're talking to a human. So we very kindly press 1 just in case they're doing this. We then sit in an infinite loop. We set I to 0. So each time through the loop, we play a sound Lenny, and then Lenny 0, Lenny 1, Lenny 2, Lenny 3, Lenny 4, and so on. And after we play the sound, we wait for silence. So essentially, this lets people have a conversation with Asterisk. So let's listen to another sound. Let's play this one.
Hello, this is Lenny.
And then...
sorry, I can barely hear you there.
and so on. So it keeps playing the sounds. There are... whoops. Wrong window. There are 19 of them. So it plays 1 through 19 and then it loops back to 7. And it just keeps looping back 7 to 19. This has actually fooled telemarketers into having long conversations with Lenny. I have some recordings up on my comedy channel, which I will post. But why don't we give Lenny a call? So, what is the number for Lenny? The number for Lenny is 114. So let's call 114.
Hello. Hello, this is Lenny.
Hey Lenny, how are you?
Sorry, I can barely hear you there.
Oh, is this better? Can you hear me now?
Yes.
I'm calling to see if you'd be interested in buying insurance for your ducks.
Oh, good, yes.
You are interested in buying insurance for your ducks?
Oh, yes. Someone did say last week, someone did call last week about the same thing. Was that you?
No, Lenny, it wasn't me. Must have been somebody else.
Yes. Sorry, what was your name again?
Oh, yeah, sorry, my name is Diane.
Well, it's funny that you should call because my...
Anyway, you get the idea. These very cleverly scripted recordings can actually fool people into having a conversation with a machine. So that is Lenny. 116 doesn't actually do anything. 117 is a demo of an echo test application, which lets you see the latency between you and the Asterisk server. Now, obviously, if I call from inside my house, they're both on the same Ethernet network, so the latency is going to be negligible. However, when I'm traveling, back in the before days, before the pandemic, I could hook up my tablet or my phone to my Asterisk server over a VPN, so I could make calls from home, from wherever I was in the world, and sometimes the latency would be quite high. And this, by the way, is a really good way to avoid extortionary hotel long-distance fees. 118 is kind of cool. It uses a feature of Asterisk called AGI, which is sort of like CGI for webs. So, let me open up this file, user local bin ping.agi, which is written in Perl. Here we go. Perl. Ta-da! Don't know what that line's doing there. Probably shouldn't be there. It's probably a security flaw, blah, blah, blah. Never mind. So basically, this just sets up the interaction with AGI. It's just boilerplate. You have to do it. I have a cache directory that holds a bunch of sound files. We'll get to that later. We sleep for a couple of seconds, and then we call a subroutine called ping with the machine name and an IP address. Blah, blah, blah. We do all this pinging, and we exit. So what does ping look like? This is what ping looks like. we ping the machine using the Unix command ping. And basically, if the machine responds to a ping, it means it's alive. We call say text machine is alive. Otherwise, we call unable to ping machine. Now, all the magic happens in say text. You've already seen Pico to wave. This actually uses a different system. This takes the text, so we're given text, and we construct a file name from it. And we change all of the dangerous characters in the file name. In other words, anything that's not a letter, a number, or a digit, we change to a % followed by 2 hex digits. That's just so we don't accidentally create like dangerous file names. Now, if we don't have a file named after the text, we call a function called Google Speech, which is a Python script I found online somewhere. I'll try to link it in the description. And this uses Google's translation API to convert text to speech, and it does a lot better job than Pico to Wave, as you'll hear. So we generate our file if we don't have it already. And then we say to Asterisk, dear Asterisk, please play back this file name. So let's dial 118 and see what ping.agi does.
Pinging gateway. Gateway is alive. Pinging Diane. Diane is alive. Pinging Diane VPN. Diane VPN is alive. Pinging Pieback VPN. Pieback VPN is alive. Pinging Pi4. Pi4 is alive. Pinging Pi. Pi is alive. Pinging Tinkerboard. Unable to ping Tinkerboard. Pinging Diane 2. Diane 2 is alive. That's all. So long and thanks for all the fish.
There we go. So if I can't sleep at night and I'm wondering if my machines are alive, but I don't want to get up and go to my computer, I can just call 118 and Asterisk will tell me. But seriously, if I'm on the road in another country and for whatever reason I'm unable to reach my machines, if I can reach Asterisk, I can at least see what's alive and what's not. Okie doke. So that's 118. And finally 119. This is another AGI that's also written in Perl. There's a theme here. And it lets me put my phone system into do not disturb mode. So I'll show you the script first. So that is in user local bin dnd mode.pl. So again, it's written in Perl. It uses AGI. We do some file locking just because we don't want two processes accessing our files at the same time. Anyway, never mind. Let's go to the beginning of the program. So this program can be called with an argument or without one. So if it's called with an argument, it's checking if we're in do not disturb mode. But in this case here, it's called with no arguments. So we skip past that if statement and we execute AGI. So here we generate, we connect to Asterisk. We get the expiry time. So if do not disturb mode is enabled, this will return how many minutes it's enabled for. If it's not enabled, it will return, sorry, I misspoke. This returns when do not disturb mode is about to expire, if it's enabled. So if it is enabled, we figure out how many minutes to go. And anyway, it's easier to just do rather than explain. But basically, if do not disturb mode is enabled, we say it's enabled for the next blah blah minutes. Otherwise it says do not disturb mode is disabled, press 1 to enable or 2 to disable it. Then we wait for a digit. If the result is 1, we enable do not disturb mode. If it's 2, we disable do not disturb mode. If it's something else, we just hang up, blah. So let's look at what disable do not disturb mode looks like. It calls clear expire time, and then it says do not disturb mode has been disabled. So what does clear expire time look like? It just removes our file. Our file here is var run asterisk dnd mode.dat. So clear expire time just nukes that file. Set expire time takes in an expiry time, which is the Unix time, and it writes it to that data file. Okay? And get expire time opens the data file if it can and reads the number that's in it. Otherwise, it returns 0. So if it can't open the file, it returns 0. Or if the line doesn't match a number, we fall down to here, we return 0. So that's clear expire time, get expire time, and set expire time. So enable DND says enter the number of minutes to enable do not disturb followed by the pound key. And then it says to Asterisk, please read a number. I don't know what all these things are, probably timeouts or whatever. If we didn't get a number, just bail. Otherwise, we get the number. If the number was 0, we disable do not disturb. Otherwise, we figure out what time it's going to be that many minutes from now, and we set the expire time. So, very complicated, but let's just do it, huh? Let's do it. 119. I need to open a terminal here. Move this up there. What is our file? So let's cd into var run asterisk. So there is a dnd mode.dat file, so watch. So here we go. Our file exists. Here it is. It contains this number, which is a number in seconds since January 1st, 1970 at midnight UTC. And this is the current time. Now you may notice that the current time is greater than the time in the DND mode file. So we're no longer in do not disturb mode. It has expired. So if we dial 119.
Do not disturb mode is disabled. Press 1 to enable do not disturb mode, or 2 to disable it.
Okay, so let's enable it.
Enter the number of minutes to enable do not disturb, followed by the pound key.
And we'll do 60 minutes.
Do not disturb mode has been enabled for 60 minutes. Goodbye.
Now, I don't know if you noticed, but this number here, which is the number inside DND mode.dat, is now higher than this number here. So it's in do not disturb mode. So let's dial 119 again.
Do not disturb mode is enabled for the next 59 minutes. Press 1 to enable do not disturb mode, or 2 to disable it.
So we enabled it for 60 minutes, but some time has elapsed, so it's only 59 minutes. Oh, I waited too long. Let me dial again. This time I'm going to disable it. So 119.
Do not disturb mode is enabled for the next 59 minutes. Press 1 to enable do not disturb mode, or 2 to disable it. Do not disturb mode has been disabled. Goodbye.
You can see that it's been disabled, and you can also see that the file no longer exists. It was nuked. So we're not in do not disturb mode. Well, that's all very cool, but how does it actually work? So I'm going to go ahead and re-enable it. I will probably cut this part out of the video, but I'm going to go ahead. Okay, I went ahead and enabled do not disturb mode, so let's go back to our Dialplan, if you remember what that is. And we'll go back to the external context. This is for incoming calls. And when I first described this, I skipped over the DND thing. So let's see what happens if a call comes in, but do not disturb mode is enabled. So I will call myself from my cell phone. Here we go.
My phone system is in do not disturb mode. If this is a very important call, please press 1 to make the phones ring through. Otherwise, please wait and you'll be redirected to voicemail.
Anyway, that's what it does. If it's in do not disturb mode, I don't want to completely block calls, because if it's really important, go ahead and disturb me. But it makes people press 1 to make my phone ring. And here's how it works. We call user local bin DND mode Perl with this argument check. So let's go back to that. So we come into the top. Here we go, we're in check. We get the expire time. If the do not disturb mode is enabled, we figure out how many minutes more to go. And if it's less than 0, we make it 0. So basically, if there's no more minutes left in do not disturb mode, we exit with status 1. Otherwise, we exit with status 0. So status 0 means do not disturb mode is on. Status 1 means do not disturb mode is either off or has expired. So we call there, and what this does is it prints out either enabled or disabled, depending on whether or not do not disturb mode is enabled or disabled. This is just Unix shell script stuff. So if do not disturb is enabled, in other words, we are in do not disturb mode, we get the response. We play the do not disturb mode announcement and we read the response. If the response is not 1, we send them to voicemail and then hang up. Otherwise, we let the phones ring through. And so this is how I can set do not disturb mode on my phone system. I'm going to clear do not disturb mode because I don't want it on. I'm going to clear do not disturb mode just by going to var run asterisk and deleting it, except I can't. I have to be root. And now my phone system is no longer in do not disturb mode. So that is the do not disturb machinery. There's one last special that I would like to show you, and that is find number. Find number is super duper cool. Let me demo it first, and then we'll look at the code. So I'm going to dial 115.
Spell a name and press pound. Just pound to exit.
Spell a name, okay.
Entry number 1. Atula Folklore.
6 1 3 7 3 0 2 8 8 7.
No more entries. Spell a name and press pound. Just pound to exit. Thank you for using this directory service. Goodbye.
What this does is it lets me type a name or part of a name on the keypad, and what I typed there was 555, so that's JKL followed by JKL followed by JKL, like J or K or L. And the only thing that matched was the Ottawa Folklore Center, which I don't even know if it still exists. So let's take a look at this file here. It's another AGI. It's also written in Perl. And so, how does this work? We have a little dictionary that maps numbers on the keypad to letters. So 2 is ABC, 3 is DF, blah, blah, blah. So here we go. We connect to Asterisk. This is just boilerplate. Here, what is this? We're connecting to a database. We're connecting to a SQL database. So let's do that. I run a database called Postgres, which is probably slightly less familiar to most of you than MySQL, but in my opinion is far better. So I will connect to it. You don't need to know SQL to understand what I'm about to show you, but it might help a little bit. So this database has a bunch of, well, 2 tables and 2 views. The table CDR, the call data record, is a table with a whole bunch of columns, which is basically the call date, the caller ID, a bunch of asterisk related stuff that we don't really care about. But what's really cool is if I go select star from, I'm going to do it from calls, which, calls or calls and callers? Calls and callers. What? Okay, here we go. Nope. Here we go. calls is a view, which is just like it's a part of the table. It's a view of part of the table, only some of the columns, the ones we care about. So if I go select star from calls where call ID like, I like, you can see that I've had a bunch of calls from the Ottawa Folklore Center over time. What happens is that Asterisk logs all calls in and out. And I take those logs and I insert them into the database that has the date, the caller ID, the source, the destination, channel. Don't worry about it. That's just like SIP or whatever the channel it went over was, and the duration is how long the call lasted in seconds. So I have a database with all the calls of anybody who's ever called me since I've installed Asterisk, as well as who I've ever called. Now, the really cool part is we can search this caller ID column. So if you've ever called me, I can search for your caller ID name and get the number. And that's what this does. It sits in a loop. It says spell a name and press pound, just pound to exit. We read a number. If something went wacko, we quit. We get the number. If something went wacko, we quit. If the number is just blank, that means they just press pound. We say, thank you for using the directory service, goodbye, and we quit. Otherwise, we take the number and we convert it into a regular expression by gluing together these bits and pieces. So if you type in the number 555, you get square brackets JKL, square brackets JKL, square brackets JKL 3 times. And then the magic happens. So we enter the main loop. It says spell a name and press pound, just pound to exit. We read a number. If something went wrong, like they hung up, we just quit. We try to get the number, and again, if something went wrong, we just quit. If the number is blank, meaning they only pressed a pound sign, we say thanks for using the directory service, and we quit. We then take each digit in the number, that's what we do, we split this up, and we convert it to a regular expression. And the way that works is, we look at this, and so if you type 555, it constructs a regular expression that's this thing 3 times in a row. If you type 234, you get A, B, C, D, E, F, G, H, I. And then the magic happens. We create a SQL statement, select, which means give me, the caller ID, the source, and the count from this table, or view actually, where the caller ID matches the regular expression I'm going to give you, and the source isn't this, which is me, so don't show me my number. And the length of source is greater than or equal to 7, because we don't want wacko fake numbers. And the source is a number. This is just to guard against internal calls that might not have a number as the source. Order by the most frequently calling people. So the ones who call the most often get read out first, and then by the uppercase of the caller ID. We execute that query. We fetch all the rows. If there are more than 4 of them, in other words, if there are 5, we say, there's too many matches, just try something more specific. But otherwise, we read out the entry. And this pretty CLID just like reformats the caller ID in a way that the speech engine can say it more understandably. If we got some entries, we say no more entries. If we got no entries at all, we say no matches were found, please try again, and we go back to the top of the loop. Stop. So we sit in an infinite loop until they hit pound. I'll demo the case where there are no matches, actually. So if I dial 15,
Spell a name and press pound. Just pound to exit.
if I put in like a whole long string of digits, that's unlikely to match anything.
No matches were found. Please try again. Spell a name and press pound. Just pound to exit. Thank you for using this directory service. Goodbye.
So that's my find number script. Now, I actually use this so often that sometimes from my desktop computer, I want to find a number. So if I go find number LKL, there we go, Ottawa Folklore. So I can use it from the terminal as well as my phone. That pretty much wraps up my Asterisk demo. I hope you've enjoyed it. I hope your mind has been expanded by all the cool things you can do with a landline. Before I go, I would like to mention that this video is sponsored. It is sponsored by me. I used to run a company called Roaring Penguin Software, which, by the way, used Asterisk. And by the way, when it was a holiday in Canada and we wanted our phone announcement to say we were closed, I used Remind in the Dialplan to list our holidays, so I never had to remember to flip the phone system into holiday mode. Go and watch video 1 if you haven't, but my philosophy is that a project is not complete until it is integrated with Remind. Anyway, I've now started another company called Skull Software Consulting. I do custom software development, embedded development, system and network administration, database administration. So if you like what you've seen, if you think that I'm creative, which I hope you do, and good at solving problems, which I hope you do, please check out my website. If you could use my services, I'd be happy to talk to you. Thank you for watching this video. Please like, and also please subscribe, and I hope to talk to you again very soon.